Hello and welcome. My name is Lloyd Gom. I'm Vice President, Business Development and Marketing for Delta Q and a part of the Zappi Group. Thank you for joining this session. Presenting, I've got Nicola Tomatis. He's the head of BlueBotics, the CEO, and also riding shotgun, as we like to say in Canada, is Julien Rochat. He's helping out Nicola with pending questions from the audience. Through the presentation, you'll have an opportunity to queue up questions in the Q&A. So just add those at your leisure. We'll wait until Nicola is done presenting to entertain questions, and I'll bring them forward. Point of introduction, BlueBotics was acquired by Zappi Group, officially late last year, but it was announced early this year. This is, and we welcome BlueBotics to the group. They're bringing significant technology on the automation side and navigation side that has been important from our customers in material handling, last mile delivery, and e-mobility. So they're bringing significant technology to the electrification side, and Nicola is going to discuss that in his presentation. So welcome, Nicola and Julien. Go ahead and take it away.
Thank you very much, Lloyd. It's a great pleasure to be here and to be part of the Zappi family. So I think this is probably formally the first public presentation we do as a Zappi Group family member. And indeed, what we present here is more from electrification to automation, because this is our topic, our job. So that's what you will see in the next half an hour or 45 minutes. So BlueBotics as a company has the vision to be the reference in autonomous navigation. Autonomous navigation being the functionality of a machine to know where it is, where it should go, and how it gets there. We have the brand Ant as our main product. And our mission is to help companies meet the challenge of vehicle automation. This can be a manual forklift supplier that wants to automate his vehicles, or it can be a producer, or let's say the designer, developer, producer of custom designed automatic guided vehicles or autonomous mobile robots. What you can see here, by the way, are few of the examples of the vehicles that are produced by our customers that go basically from a payload of 100 kilograms up to a payload of 100 tons, and any kind of vehicle type, indeed an automated forklift, a tagger, unit load, or even a cleaning machine, and any kind of, again, a type of autonomous vehicles for industrial applications. So what we will talk about today is natural feature navigation. We will get into more details later on, but basically what our technology is doing is that it allows a machine to be automated. And in terms of technology, we use indeed what is called natural feature navigation, which means that the technology uses the laser information, so measuring the shape of the environment to build up a map and then recognize the position of the vehicle thanks to this data from the lead scanner. And that's indeed the reason of the name natural feature, because it's based on the shape of the environment which is naturally available. Now, the idea here is not so much to talk about what we do ourselves, but more to have a broad view on why we should go from manual vehicles to automated vehicles. So we start this presentation with the question, why should someone automate, or why should you, maybe as vehicle supplier or forklift supplier, start automating your own vehicles? Well, the first reason for that is that there is a growth opportunity. The market is booming. You know that the market of manual forklifts is a great market, but it's not growing so much. So the AGV or automatic guided vehicles or any kind of automated forklift, autonomous mobile robot, is the other way around. It's a quite a small market, but it's growing incredibly fast. In this sense, the opportunity for the growth comes from the rising demand. So everywhere we have to increase productivity. In order to increase productivity, we need to automate more and to have more delivery. This is mainly driven by a growing middle class globally in the world, but it results in every company having the opportunity to sell more and therefore having the duty to produce more. Then again, why should someone automate? A second very important reason for that is the hiring challenges. So it's becoming more and more difficult to hire production and warehousing employees. This is due to the aging society, but also due to the people being more interested in doing other jobs. In USA, we see a huge problem today in hiring people for warehousing and production lines. So that's another push to automate more. And both of these reasons are more related to demographic change. On top of that, unfortunately, we had to test another important point that is pushing for automation, which is resilience. There, the COVID was a hard test for this, and let's say the inshoring trend was already there, but now this has become even more important during the COVID phase. And finally, to talk about the most important drivers for automation, we report also the need to stay competitive. In the past, this was more a problem of highly developed countries because production there is not easy in terms of cost. And we saw, especially in US, that this was offshored a lot kind of 20 years ago. And we have, again, as we said before, a kind of inshoring since more or less 10 years. It was in 2012 that President Obama did a presentation about, indeed, the importance of production and manufacturing for the country. And, well, this indeed was important for developed countries and is becoming important everywhere because the labor cost is increasing even in growing and developing countries. So these are the four main drivers we see that are creating a growth opportunity that could motivate someone moving from manual vehicle to automated vehicles. There are then benefits that are related to the automation. Of course, if you are a supplier of, let's say, manual vehicles, manual forklifts, one reason to move or to start doing also automated guided forklifts is to attract new customers. So it's not just about replacing manual vehicles. There is more and more new fully automated greenfield plants and logistics and distribution centers that need more job. And that's where it makes a lot of sense to place automated vehicles. A second benefit of automation is that indeed one can improve efficiency. This can be improving efficiency for the customers, but it can even be improving efficiency for themselves. So maybe a company today building up vehicles. It happened already in the robotics field, in industrial robotic fields in the past. So even the robotics, let's say the industrial robots, they were produced manually in the beginning, and then their production has been automated more and more. And this is what can happen also in the field of forklifts and industrial vehicles in general. Another benefit of moving in the direction of automated forklifts is that this field is seen as let's say, attracting for employees. So today, indeed, as we just saw in the slide before, hiring people is becoming more and more a challenge. So having a product in the portfolio which is going in the direction of automation can help to attract and to retain talents into a company. And finally, again, for a company today more in the field of manual forklift, it can be interesting to move also towards automated vehicles in order to modernize the brand. Let's say the perception of lead trucks can be seen, let's say without automated forklifts, can be seen as old school. If someone now adds also an automated one, it can kind of make the brands being more attractive for the customers also. So these were the points we wanted to share in terms of why someone should automate his products or his vehicles. Now we have a few inputs about how to automate. And we are sharing 5 things we think are important. So if now in the audience there is a company that has indeed manual products and wants to go towards automated vehicles, there are a few questions that can be, or few things that can be considered as important. The first big question that we have that can be both in terms of our customer that want to automate, but also end customer that want to decide which kind of product they should buy. The question is, should someone automate manual forklifts or manual vehicles, let's say vehicles that have been designed to be manual, or should someone develop a completely new vehicle from the ground up? And that's an interesting question. What we see from the experience in the field, of course, there is a huge advantage in automating existing standard forklifts, because there you have, of course, quality, you have volume. So also the advantage of the price and say the cost that is lower because you have higher volume. This is a cost-effective way to create a new vehicle. On the other hand, if you build up a new vehicle from scratch, the advantage is that one can add more custom-specific functionality that could be better suited for a certain application. Examples are conveyor belts, robotic arms, etc. So on one side, for applications that are more standard, like again moving a pallet, automating a standard forklift can be the good solution. On the other side, if we are talking about applications that are more custom specific, it could make sense to design a vehicle from scratch. Second question that we propose to consider is, of course, that's our field. Which technology should someone choose in order to automate a vehicle? And the question, of course, is also related to the application. Which kind of environment you want to use the vehicle? Do you want a generic solution, a specific solution? For this, we will not go into many details today because we don't have the time. But we invite you, if you are interested, to take a look to our website or contact us. We have analyzed the different technologies that are available. So the different technologies are the first one that was used in the past, line following, which means having a kind of cable in the floor with inductive sensor to measure where it is, or magnetic tape. It can be with tags. Tags can be magnets, or they can be RF systems, or other type of tags, indeed optical tags. There is laser triangulation. So this is about putting a laser on the top of the vehicle and then having targets, reflective targets that are placed, structure that are placed on the walls in order to create a triangulation, calculation of the position. Vision guidance that allows to use indeed the vision system to see the surrounding and try to get the position thanks to this sensor. And then there is natural feature that was briefly presented before, and then our natural feature that has some other specific characteristics. one key point here, you see also then the different criteria that we use in order to assess the quality of a technology. To make the long story short, there are three different key points. One is what is the cost of commissioning, installing a system. On the other side is what is the cost of maintaining and maybe updating and modifying the system. And in between, we have all what has to do with the performance of the system. So the accuracy, reliability, the speed that the vehicle can do. And again, depending on the type of vehicle and type of application you have, you may want to have more flexibility or more reliability. Of course, we are in a lucky situation to propose a product that can do most of them in a quite ideal way. But again, this is not the goal today. That was just to give some overview. I think in terms of the question, which technology you should choose, again, it's more important to understand that there is for automated vehicle, there is a commissioning, which is not something you have with manual forklifts. If you say a manual forklift, well, there is a customer coming, you show the vehicle, say yes, and then you sell, and that's it. If you sell automatic guided vehicles, the key point is the integrator. It's the one that will go to the customer site doing the commissioning. And at that moment, the cost of infrastructure, the installation time, or the commissioning procedure is fundamental on one side. And on the other side, is important then to have the quality of the product, the quality of the navigation, and then also the automatic vehicle in order to have an operation that works perfectly and do not require human intervention. Third point, again, if you decide now I want to move from manual forklifts or manual vehicles to automated vehicles, the question is, do your staff have the skills in order to do this job? Because as I just said before, it's not the same producing and selling manual vehicles compared to producing and selling and commissioning automated vehicles. So it's very important to find out if the team that will be dealing with the automated forklifts or automated vehicles has the right skills, the right education, the right experience in order to deal with this new kind of products. And point number 4, we should not forget also about the battery and charge approach that is used in a vehicle, because it has a very important impact. Especially in the last year where we moved from lead batteries to lithium batteries, basically the ratio between the operation of a vehicle compared to the time spent charging has dramatically changed. So by choosing the right battery system, and by the way, the right charging system, which of course you can discuss with all our partner companies in the group. So choosing the right battery, the right charging system can have a huge impact in the performance, because you can move from a system, or say a vehicle that is working 50% of the time and charging 50% of the time. You can move to certain vehicles that can even work 90% of the time and be charging only 10%, again, depending on the battery technology, the charge technology. And depending, this is also very important, on the strategy that will be used to charge the vehicle, which depends on one side on the technology of the batteries and the chargers, but also on the operation of the automated system. And of course, again, these are the points to consider if you want to start doing automated vehicles. Very important is then also to choose the right partner to do that. There are few companies that try to do everything internally. Why not? It can be an approach, but one has to be aware that this takes years. It's really a huge work. So the standard way for company doing manual vehicles that want to enter the automation market is to work with a partner, and the partner should be selected by taking into account the experience, the references, make sure that the technology is proven, that the partner is strong enough to provide close support, meaning that the partner is available also on site to make sure the integration works well, that the automation system is very well integrated into the product, because this at the end has to go to the market and has to work 24/7 in a completely autonomous way. By the way, a very important point is also the question of where you want to improve and where you want to make a difference with an automated product. The interesting point, and that's again very different compared to manual vehicles, is that let's say in a kind of quite simplistic way, people say automation is 30% about the component cost and is 70% about the integration. The integration being, on one side, the time spent to integrate a component into a vehicle, but I would say even more important is the time that is spent then to integrate a vehicle, automated vehicle, into an automation process. And this indeed, in the automation field, is rule of thumb defined as being about 70% of the cost. So if someone wants to reduce the cost, it should first focus on the 70% integration, commission, etc., and then on reducing the cost of the vehicle itself. So let's say the component. This is an example of an automated forklift. It gives just an idea to you. So I expect, since you are part of this conference, that you have a kind of quite good overview about the different components that can be found in the ZAPI group. So you can find motors, you can find motor drive, you can find chargers, other HMI, etc. Now, the idea when we put an automation system into the game is to, of course, this is just an example for this kind of vehicle, is to put the navigation system here in between. And this system will, on one side, as I was explaining before, read the data from the laser scanners, which allows to indeed do the mapping the environment, and then localize. Of course, it is also used for safety, this information, but it is done directly in the safety system, not in our system, in the navigation. And then you can connect, well, a wireless system because you want the vehicle to be able to, let's say, talk or discuss with a fleet management, which then talks to the company software system. This could be a warehouse management system, an ERP, or how do you call it, manufacturing execution system. So this is on one side. On the other side, can be CANopen, can be another protocol. We use also Ethernet IP or others. But this will be the interface to the different motor drives. So a traction drive, steering drive, it's a tricycle system, and also an hydraulic system to control the fork. And of course, you have then a hydraulic motor, the traction motor, and the steering and traction system of the vehicle itself. There will be also encoder somewhere that will allow to measure the speed of the motor. So that's what you see here, the encoders for the traction and the steering. And all this then is reported to the motor drives. And the idea is that the navigation system will know where the vehicle is, will plan where the vehicle should move, and it will then give the speed commands to the traction and steering driver to move around in the right way, and of course also the commands to the fork in order to set the right place, right height of the fork to pick up and place pallets on the right position. So again, that's a kind of simple setup, but it allows to do already the automation of rather complex vehicles or forklifts. One could do a much more complex system, but our philosophy is to try to keep the architecture of the vehicle as simple as possible, because this allows to automate much faster than with a complicated approach. By the way, the idea is that with this kind of approach, one can start working with us or even with someone else much faster compared to more complex architectures. And it is also easier in the future if someone wants to change technology to switch from one technology to another. This was the part about how to automate. Then we also raised, let's say, we bring you 3 questions that are common for someone doing automated guided vehicles or manual, let's say, automated forklifts or autonomous mobile robots. So point number 1, a question that comes very often is, what do I need if I have more than one vehicle which is automated? So in this case, we talk about a fleet management system. So basically what is required for that, I may just run the video here. It's a little bit bumpy, but it seems it works. So what is required? First of all, if you have more than one vehicle, of course, you are sharing, let's say the vehicles are sharing the different, let's call them streets or ways. So one needs to have a traffic management system that allows to know which vehicle can go and which vehicle has to stop when there is traffic indeed in a certain place. A second point, which is fundamental, is that if there is a fleet of vehicles, one should define which vehicle should do which task. So this we call scheduling. These are the 2 most important functionality that one has in a fleet management system. So I just repeat, on one side is scheduling, which means that one has to decide which job has to be given to which vehicle and when. And the second one is to then coordinate all these vehicles moving around by having a fleet management system. How does it work? Well, the idea is rather simple. In this case, is to have a centralized system that is basically talking regularly with all these vehicles and knows indeed what the vehicles plan to do, where they plan to go. And with this in mind, the system can then indeed coordinate the different jobs that have to be done and the different routes that the vehicle are traveling. There is also an emerging question. So there are more and more end customers that say most of the time they need more than one vehicle. They need different vehicle types. They may need vehicles to move pallets, but also vehicles to move boxes or cars, etc. So in this case, there is a need that is coming up, which is indeed having different vehicles types or even different vehicle brands working together. And that's indeed a key requirement from the market. There are very few suppliers that can solve this problem. It's rather difficult to have this. There are installations, for example, at Volkswagen, where you have 3 different vehicle types and 3 different streets, because every vehicle needs a seat because they are not able with the different fleet management to share the same space. And of course, this is not ideal in terms of cost of the square meter and cost of the fleet management itself, because you have to install 3 times 3 different systems. And that's where we think we can make a difference in the future, because with our system, we can make indeed different type of vehicles and different brands work together. Finally, one of the key points with automated vehicles is that most of the installation are done to be scaled up in the future. In most of the cases, an AGV system is installed to solve, or let's say to automate one of the processes or one of the sub processes, with the idea to later on automate more. And that's also a key requirement, because it means that one cannot just make a small act to make sure that the current sub process is working. It is important that if tomorrow this is extended by automating other processes or just by adding new vehicles to make more production or more in general output, well, one has to be sure that this will work also in the future. So it's fundamental that the technology that is used is scalable also for the future. A second point that to be honest, we also underestimated at BlueBotics in the beginning, kind of 10 years ago, is that the vehicle itself, or the vehicles, they in order to do their job, they have to have interfaces. They need interfaces, well, on one side to the supervision team that has to know how the system is performing, if there is something to do, if there is maintenance, etc. That's, let's say, something that is relatively clear. But the other point is that it's important to have an interface to, in this, the business software, as I said before, could be a warehouse management system, manufacturing execution system, or an ERP. That's what we see here. And there are in reality exceptions. There are systems that are installed that only have this part here because they are only doing very simple tasks that are started by having a button or by having a simple interface again. But I would say that the most typical installations are really installations where the whole system is integrated to the business software. And basically, an automated vehicle is a kind of arm of the business software that can not only track what's going on, but really start moving things around, like moving pallets, moving goods, semi-assemblies, etc. That's one part of the story, which is very important. In our case, we have a very clear and simple API, so application programming interface, which is standardized and allows to build up this link between the fleet management that we call Anselmer and the business software in a rather simple way. The second point that is very important is that it is quite seldom that a vehicle can work by itself without interacting with anything else in the physical world. And in this case, one also needs an interface to external equipment, which can be the simple thing could be an automated door, could be an elevator, but it could even be, if you have a production process, could even be that you have an equipped machine, a production machine, where you have to break pieces and then put the pieces into the machine, and then this is doing a production process, then you have to take this away and bring somewhere else. So these are kind of interactions, physical interaction, that must be coordinated by the AGV systems or the fleet management, and need then to have concrete physical transfer from vehicles to equipment and vice versa. Third point that we want to raise, that is also, let's say, a trendy point, is can AGV also operate outdoors? That's a quite new requirement coming from the market. And I think the short answer is yes, one can automate vehicle for outdoor, but one has to be careful that the environment is less structured, so it's more difficult to have indeed all what has to do with navigation, with localization, with also detecting in a safe way obstacles. So safety is also more challenging. There is today only one single brand that provides safety laser scanners that are certified for outdoor. The weather conditions can have an impact on the sensor and can therefore also have an impact on the performance of the vehicle. So one has to be careful about also choosing the right type of sensors for the outdoor. And also, in general, vehicles working outdoor are working in a kind of mixed environment where you also have cars, trucks, etc., that are manual driven. And in this case, one has to also coordinate manned traffic with automated traffic. So again, the short answer about the question, can someone work outdoor, is yes. No, but it's not so easy. And so please don't try this as a first project. It's better to, when you move from experience with manual vehicles to automated vehicles, it's better to first have a normal application indoor, and then to have application outdoor. Here, I may have a question for Lloyd, because this would be all the part about the technology, why to automate, etc. And now we have examples of customer projects. So should we open the session for questions at this stage, and then go to the examples and open it again later on?
Sure. I mean, it's your choice. That can work.
No, you are the boss.
Okay. We don't have any questions yet coming up in the chat. So maybe
Okay.
go through the projects, and then we can pause in a few minutes.
Sure, let's do that then. And then your job, audience, is to invent questions later for the end of the presentation. Okay, so the idea here is that we would like to share a few projects that we think are relevant with you to give you a better idea of what is an application with automated guided vehicles, automated forklifts, etc. So we start with project number one, which is an automation of production of parts for automotive. And so this is a project that has been done by our customer F3 Design in the USA. The end customer, so the company automating their processes, GCOM Corporation USA. As I said before, they are in the automotive market. They have more than 600 employees. And they used indeed these vehicles, the Nipper, those that you see here, the white ones, 5 of those vehicles to move around stuff for production in their plant. And they used the unserved fleet management system with an interface to their ignition SCADA solution that was again indeed implemented with the API that we provide. So the challenge for them was to optimize headcount. They have found out a lot of processes that were quite inefficient in their production plants. And there was a lot of time wasted by human resources that were working and searching for things. It was quite unstructured. By the way, that's also a key point. If someone wants to automate a process, one should first very well analyze the process and structure it, because it's not so easy to directly automate manual processes. And that's what they did. So they had to figure out what were the real movements of material that they needed for their own operation and production. And that was the starting point of the project, which was indeed the challenge. In the past, this was used by manual-driven vehicles, so they were picking raw material and raw components and bringing this to the assembly lines, and then collect the finished goods to bring them back to the warehouse system. And they had also some constraints, so very limited space. So they needed a lot of agility, let's say maneuverability of the vehicles. And they needed to have vehicles that were very low. In general, also, since it is a building that was already there and an operation that was already working, they wanted to have minimal infrastructure changes in order to use automated guided vehicles. And that's, let's say, these 3 different constraints are the main reason for them to choose the F3 Design Nipper vehicle, which is a very compact vehicle. It can move up to 1 ton. And other fundamental point is a vehicle that can turn on the spot. So it's a differential drive system. It has basically 2 motors there, and they can really turn on the spot to take as few space as possible. And so the statement of the CEO of the company was that as soon as they saw this vehicle, they said, "Oh, that's clear. That's what we need for this application." In terms of software, as I said quickly before, the BlueBotics and server was interfaced with the initial SCADA software. They also developed custom-specific interfaces to monitor the operation of the vehicles. Here you can see a video showing indeed a typical movement. You can see this vehicle that can indeed, as I said before, turn on the spot. Here, this is not the smallest hallway they have. They have some that are even smaller, but you see that there is not so much room to have larger vehicles. And if you should do more complex maneuvers compared to the one that they were doing here, it will be difficult to pick up the pallet. As you can see also in the background, there is a lot of stuff everywhere. It's a big work for them to move all this. Not everything was completely automated, so they decided to automate first the processes that needed more movements. And here you can see the vehicle bringing empty boxes to the assembly line. Again, with this moving on the spot, which was fundamental because of the very limited space. So they, at the end, they had 5 vehicles doing the job. They had more than 150 positions where they had either to pick up or deliver pallets, and more than 65 assembly lines were automated with this solution. The result of that is that they could reduce the resource needed to move around all this thing of about 73%, which resulted in a break even of after 2 years. And now they are evaluating to add also rich track vehicles or another type of vehicles to automate all the processes, which again shows you the importance of the point referred before, like the fact that the system must be scalable, because you start with one process and then you want to automate the next one. That was one point. And the other one is that you need to be able to use today the deeper vehicle and maybe tomorrow another model or even another brand in order to make everything work well and automate all the processes that you want to automate. So sorry, need some trick. The second example we want to show you here is the automation of production of semiconductors. This is a production in Switzerland. So it was ABB Semiconductor, but this ABB unit has been sold to Hitachi. So today it's called Hitachi Power Grids. The industry is high-tech semiconductors. The vehicles used there are 14 vehicles called Mini. This is a little bit an exception because these are vehicles that we provide ourselves for this plant. The software used is the BlueBotics Answer, again, as fleet management. And the business software there is say a manufacturing execution system from ABB called ABB Ability Manufacturing Operation Management System. The challenge there, that's a quite interesting one. Is production of semiconductors in Switzerland basically is too expensive. Let's say if you do it in the normal way, because the cost of labor is too high. So back in 2000 and when was this? Must have been 16, 17, I don't remember. We had the first discussion with the team at ABB that was telling us really clearly it is this plant in Lenzburg, Switzerland, is either we automate or we close it and we offshore this to a place where it is we have cheaper labor. So the goal, or let's say the challenge, was to increase efficiency to remain competitive in Switzerland in order to keep the production in Switzerland. The project was named Project Genesis. You can search it on the web and you'll find also some videos and some documents. The task, well, again, it's a production line. Semiconductors is probably the field where production processes are the most complex ones. So the idea was to automate all these processes with some equipment, so some machines that are doing some production processes, but then the vehicles are moving the semi-assemblies from one production step to the other, and also later on to the test facility that is testing every single semiconductor to make sure that the quality is guaranteed. Again, the solution then was provided by us. Of course, they put their own logo. I think they are still using the same logo, even if today it is Hitachi. I should check again. And here you can see a few images of that. So that's indeed a cart full of these semiconductors that are moved from the production to the testing facility. And that's a fully automated testing system that is taking every single semiconductor and testing it fully. The whole project is quite impressive. So their goal was to say, I mean, the plant in Lenzburg, I don't know exactly, but it was probably about 300 employees there, with about 100 employees working indeed in the clean room. So that was also a key constraint, by the way. So clean room ISO 5. standard. And the goal was to dramatically reduce the people that were in the clean room. The job in the clean room is complicated because you have to dress up for that. The space is limited. It's very expensive. So there was a significant increase in productivity where basically they plan to move from 100 people in the clean room to only 2 to 5 people that will remain in the clean room. This is, of course, a reduction of jobs on one side, but the alternative was to lose 300 places. So the other 200 that are working around the plant, they will stay in Switzerland with a fully automated production plant that is making the difference and allows ABB, or let's say Hitachi, to keep this production in our country. The quality also was improved by having everything automated, because you can better handle the quality and also the quality control. And this project was within several hours, so factory of the year, etc., for the implementation of this automation system. The last example we want to share with you, it is a completely different field. It is still automotive, let's say, compared to the first one, but it's not producing automotive components for the cars. It is about producing tires. So the project there, let's say the company is Michelin. The plant is in Cuneo, Italy, a very good place where you can have a very good wine and very good food. And as I said, industry is tire production. There they have used 6 quite huge vehicles. I don't know if you see it here, but you will see it later on. Basically, this is a truck, a wheel. So I think the vehicle is about 11 meters long. The software used to interface the custom software is, in the case, a custom specific software. The challenge they had is quite interesting, because the old plant there was growing up step by step, and the last big development they did, I may go forward and come back, was to build up all this confectioning building here. Basically, that's where you bring all the produced tires and you prepare them for the day after, in order to put all these tires into trucks and to send them around Europe. So all the production takes place here, and all the preparation of the product takes place here. And in between, you have this huge street here where every single tire produced has to be moved. In the past, this was done by manned trucks, so diesel manned trucks, and the idea was to automate this process. The distance is 0.9 miles, 1.5 kilometers, and it has to work 24/7. So very, very quickly, sorry for those that do not speak Italian, but the comment is in Italian. I can, of course, translate that. So there are several tens of thousands of tires produced there every day, and they are then moved from the production to the warehousing, which is this building here. And here you see one of these big vehicles, this piece that are picking up all the system. This is completely automated, the transfer. And then on the other side, as you see here, the transfer of the tires is completely automated. And then it moves this 1.5 kilometers to the other side of the plant in order to deliver this to the warehousing and preparation system for the delivery via trucks. Of course, all this was completely developed to be fully safe, outdoor, with sensors that are designed for this. Without going into details, this gives you an overview about the project. Of course, this was a huge improvement in efficiency. Also, a very important cost reduction. Improve safety, because all the automated processes guarantee safety. And also, from an ecological point of view, it was extremely interesting, because it represents a reduction of 50 tons of CO2 per year. Voila, that was the presentation of BlueBotics. Now, both Julien and me are available for all your questions, and we are ready for you.
Nice job. Maybe just to get started with a couple of questions. You were yourself and Julien were at the Modex show in Atlanta recently, just last week, right?
Absolutely.
How was that experience? Do you have any sort of key industry takeaways?
Julia, do you want to start?
Why not? Well, it was good to be back on the show, to be honest, after a couple of years staying home, not being able to travel. And I think, well, it was good to see all the customers. We had several customers exhibiting at the show. And we also saw that there was a huge interest from a lot of end users. So many companies that linked to the COVID or not, I don't know, but realized the importance of automating factories and all the processes. But obviously, several reasons were raised by Nicola. I think the COVID did not help. And well, it might be good, it's good for bad for the automation after all. And then we had, I think for the first time, we had a very nice demo at the booth showing different vehicles of different types working together, which was a great point of attraction for prospects and end users.
Excellent. For OEMs, and you went through several sort of application examples. Obviously, the applications could be wide ranging, and we see new ones from time to time. For OEMs, what advice would you give them in terms of sort of time frame to add automation to an existing machine? What does that sort of development timeline look like, or can you generalize?
Yeah, I mean, there are related two questions. The one is, when should someone start doing that? And that's already a very interesting question. There are OEMs today that do not have automated vehicles, and one of the key trade-offs that has to be taken is that today the market of manual forklifts is indeed much larger than automated ones. So the question is, when should someone start? I think that, as Julien said, if you would have been last week at the Modex, you would have felt, is that the right word, that it's time to start now, because the market is moving. Now, in terms of how long it takes to automate a vehicle, we have quite some experience in doing this kind of job. I think that we have helped our customers to automate more than 100 different vehicle types. So we are very used to do that. We have a process in place, and we say that if someone is able to go full speed, it's a job that could be done, let's say, in 6 to 12 months, or even less. We had some customers going to the market in 4 months. But the truth is that one has also to coordinate, of course, with the different companies, etc., and the rhythm of the OEM itself. And our experience shows that in average, it takes about 1.5 years from the day we sign to the day where a vehicle is really in operation to the end customer. Because this is also a key point. We see that the real benchmark is not really to have the vehicle ready automated. The real benchmark is to have one automated vehicle in operation, because the time where you have a vehicle working and the time it takes to find the customer, convince the customer, and have a reference can have a big variation. And in order to sell more later on, you need the first reference.
If it's so, a follow-up question: if it's, let's say, the example of an AMR, a robot, and so it's not an existing piece of equipment; it's in development. When in the cycle would you recommend, with full knowledge that it's going to be automated, when would you recommend an OE start on the automation side of the project? Would it be at the very beginning, middle? What sort of advice do you have on that?
Maybe I can add something to what Nicola said. We have different customer types. Some are AGV manufacturers. So they will have a deep understanding of what is an AGV, how to install it. They will have the team, the marketing team, the sales team, the customer base. So these are the one that should go the fastest to market, because for them, going to our type of navigation is a kind of option. they would go from line following to natural navigation. On the other side, we have the very large companies like one we see on the picture here. These also have experience, but they will face the certifications, the internal validation that will be the long-lasting part of the job, or the integration. And then the last one would be companies that are willing to automate, buy a manual forklift and automate it, and that most of the time have a little less experience than the others. And we see from experience that these are the longest processes. And for all these guys, the sooner you start, the better it is. If you start with existing components, you might have to change some of them. You will have to do some mechanical redesigns. If you start earlier in the journey, I would save some time.
So to summarize, the less experience you have with automation and with vehicles, the sooner one should work with the automation company.
Excellent. One softball question for you, because it just to help people engage. Given that you're new to the Zappi group, and a lot of folks watching, you're new in the sort of the Zappi experience. What's the best way to engage with BlueBotics? How would you recommend they engage with you guys?
Well, any way you like, you can contact us via the website, send us an email, come to Switzerland to have our great Swiss chocolate in the office, or come visit us at the trade shows. Next one is Logimat in Stuttgart in 1.5 months, something like this. So we are very happy to welcome anyone with any kind of communication channel. That's really up to you.
Okay, excellent. Yeah, they can do it, by phone, email, or just join your subscriber list, I think, off your website, right? So a number of ways to engage.
Exactly, but this unfortunately is without chocolate.
That's right. Okay.
Lloyd, there is a
thank you very
question.
much.
It seems that this effort are most for heavy and primary industries, and he supposed to do the current effort necessary to accomplish the task. Do you see this process scaling down to the secondary and boutique industries, and over what time?
Oh, that's a very interesting question. Robotics, we always tried, and we have the discussion, I think it was last week also, we always try to have any kind of application. It is true that those that really exist, where the return on investment is clear, etc., are more into either production or warehousing. But we try to also have always some, we call them crazy projects open. So we did not really talk a lot about that, but we have a professional cleaning as an application, which is not a typical industrial application. We have developed a pilot project with the company Sita in Geneva to have let's say a check-in kiosk that moves around in order to optimize the flows of people in the airports. So in this sense, from a technology point of view, I think we have a lot of potential applications. But of course, the big challenge is to find the business model and the right price model in order to make sure that there is a return on investment on that. So this process scaling down to second-hand boutique industries, it's already happening right now. Now, again, for proven application where return on investment is clear, it's much easier to enter the market. For those that we have to invent or create, it takes more time to go to market. Again, cleaning, I think, is a good example of a successful application, which is not really in the primary and heavy industry. Another one is hospital logistics. Still, it is logistics, but it's really about moving around what is in an hospital. So it was one of the first application in HVs that was going out from the, let's say, from the production plant and reaching a more service robotics or service, let's say, application.
Good. Thanks for the answer on that. And I think we're out of time. We're in the last 10 seconds. So thank you very much.
Oh, that was
nice job. It's been a full hour. Thank you for everybody. And thanks for joining. We appreciate your support.
Thanks, Lloyd, Valentina, for organizing the event.
Yeah, thanks to all of you. And of course, contact us if you have any question.
Yes. Thank you.
Thank you.
Thank you. Bye.
Bye.